Okay, perfect. I hope you can see my screen. So yeah, welcome to today's webinar. I hope everyone had a great lunch in so far as here in Europe. I very much welcome you to this Prisma webinar, starting slowly after the summer, the new academic year, and also an important year in terms of the policy process, in terms of climate policies. I work at CMCC and I co-coordinate the project Prisma, which stands for the title that you can see here. Its focus on basically on net zero pathways and is trying to improve models, in particular integrated assessment models, across various dimensions and also at various scales. And you can see this here represented by the prisma, which we choose as our kind of logo, because we basically need to bend this ray of light or emissions that you can see here, of course, towards net zero. And we look at it from different angles, starting on the justice of this transition, implications and for and from innovation and finance, biodiversity and climate impacts, so a large number of aspects which are relevant, and lifestyles and circularity, which is the work package 4. And this is particular topics that we have today as the core topic of this webinar. The project started in 2023 and runs another 1.5 years just to finalize. So happy to have this webinar along these issues of circularity and lifestyles, which is also an important factor of the transition. Just very briefly, so we work with a large number of different models, of different types of sectoral models or specific models, and focus on the application on the net zero pledge which the European Commission has given, but also, as you know, many other countries and regions have done so. And we also have a lot of databases that we use, and some that are also relevant for this work here presented, looking at things like life cycle assessment, looking at things like material flows, all topics, and a lifestyle module that we have been developing, and we have here two people that have been largely working with it. So that's really one of these 4 main areas that we're looking into the Prisma project. Today we have first Darius Corbier, who is a junior scientist at CMCC here in Milan, who will present his work on kind of combining issues of circularity, but also with data and modeling, including also lifestyle changes. And then after him, we have an intervention from Hazel Pettifor from Oxford University, who's also part of the project and has been largely working on the social, let's say, dimensions, lifestyle change, how people adopt new technologies, new demand side applications, and etc. So coming from this social dimension as well. Just a few notes on the webinar. This is a standard, let's say, Zoom webinar, so you can raise your hand if you have questions or write your question in the Q&A box also throughout the webinar, and then I will pass through and go through the questions and pass them to the speakers as we go on, and we have time at the end for 10 minutes or so of questions and answers. You can also raise your hand, and you can also, if case you want, intervene, let's say, and I give you the floor to ask your question orally. Yes, I think we will also record that video, and it will be made available on our CMCC YouTube channel, so it can be seen afterwards for people interested in that. With that being said, thanks a lot for joining today and having the time. We always welcome questions, comments, suggestions, and also doing this webinar. So please raise your hand or write it in the Q&A box. And I give the floor to Darius, who will start with his presentation on how incentives and behavioral aspects shape consumers' response in this field, on the demand side and from various angles. Darius, the floor is yours. Thank you.
Yes, thank you very much, Johannes, for the presentation, for the introduction. So hi, everyone. I'm Darius Corbier from CMCC, presenting today with Hazel Pettifor from Oxford University. And today we will explore how economic incentives and lifestyle changes can incentivize consumers to engage into specific circular economy-related consumption activities. And we will also delve into the implications for wage generation, resource use, and and CO2 emission. And looking at going beyond this waste use and resource use implication, we also look at CO2 emission. It's all the more important as you see more and more papers that try to ask themselves, how could we conciliate circular economy and climate change mitigation goals? Because circular economy, besides its main goal being decoupling growth from resource use and waste generation, circular economy can also tackle also challenges such as biodiversity loss caused by the mining and extractive industries, but also resource security and greenhouse gases emissions mitigation. However, so you have different papers. Some papers say that we can have some synergies between both goals, especially in countries with high incineration or landfill rates, causing air pollution issues, and also for countries where you have in which you have high carbon and resource intensive production and consumer systems. However, some authors are very cautious and say we might have also some potential trade-offs between circular economy and climate change mitigation goals, especially for the recycling of specific products that can be more carbon intensive than buying a primary material, or extending the lifetime of goods through, for example, repair that can be less environmental beneficial than replacement when fast and high improvements energy efficiency are in place. Or also you have some more and more papers that are pointing out sharing economy as actually less environmental friendly than ownership's model. So basically, we try in this paper to assess these potential synergies and trade-offs between circular economy and climate change mitigation goals, and we do it for Japan. So the main reason for Japan, like 2 years ago when we started maybe 3 years ago when we started working on this model and on a lot of papers, the main reason for Japan is that you have a lot back in time. We have a lot of data regarding material stock and flows and waste flows. So this is one of the main reasons we focus on Japan, and also for other contextual reason. Japan has been one of the first countries in the world to implement circular economy strategies, especially through its sound material cycle society. And while this sound material cycle society that is mainly based on the 3R framework, reduce, reuse, and recycle, so the sound material cycle society mainly focuses on recycling and diverting waste away from landfilling. Well, you can see here, so the sound material cycle society was implemented in beginning of 2000. You can see that the beginning of 2000, the tip of waste generation here, waste generation has significantly decreased until 2010, but since 2010 this decrease has been slowing down a lot, and since 2017 this waste generation decrease has been stagnating. So basically Japan still generates a lot of waste. Second of all, while Japan has been very successful in diverting waste away from landfill sites, Japan now relies a lot on incineration for its waste treatment. More than 75% of its waste is incinerated, which is way above the OECD average. And Japan, given that Japan is a very resource-poor country, relying a lot, being highly dependent on imported resources, and especially primary resources, creates a lot of vulnerabilities in Japan's economic resiliency. So basically, what we wondered is, what if Japan moves beyond this 3R framework that mainly focuses on reduce and recycling? What if Japan prioritized the top ladder of our strategy? So for the circular economy, you have many different circular economy strategies: refuse, rethink, reduce, reuse, repair, refurbish, remanufacture, repurpose, recycle, recover. I think that now we have a 10th our strategy. So what if Japan moves beyond this 3R framework and also focuses on the top ladder, that also focuses on consumer-focused strategies such as repairing, energy using goods, rethinking of new ways of consuming through, for example, new business model as sharing models, but also refusing the things of refusing things that you do not need, and what are the implications for the world, for the road toward circularity, but also net zero emission pathways. But when we look at the literature about these consumer-focused strategies, the literature said, okay, good, we can focus on these consumer-focused strategies. However, there exists a lot of barriers, economic barriers, technical barriers, but also behavioral barriers that constrain the engagement of households and consumers into these consumer-focused circular economy strategies. And today we're going to mainly focus on the repair of energy-using consumer goods, so the repair of cars, big home appliances, small home appliances, and there are significant barriers to repair, such as high repair costs, the fact that the repair market are a credence good market, so this credence good market reflect the fact that there's a potential asymmetry of information between the technician who repaired the good, a car, and the client who wants his car to be repaired. Usually, as a client, you do not know what is the quality of this repair, and if the cost that is asked for this repair is actually a fair cost. But also another barrier to repair is the perceived obsolescence of goods due to rapid technological progress and the mass marketing strategy of firms that push consumer to consume a lot, to consume on, and to have a high turnover of their energy using consumer costs, and also the availability of low price and low quality of consumer goods that disincentivize household in engaging into repair, rethink, or refuse. And also another barrier that has been that is more and more documented into the literature, that there might be some potential negative effects on CO2 emission of these strategies, especially repair and rethink. So when I talk about rethink in this presentation, I mainly refer to sharing models. And there might be conflicts between a trade-off between SDG 12, that is about sustainable production and consumption practices, and SDG 13, that is about climate action. And if we look at the European experience, there's a third issue with this consumer-focused circular economy strategy that is related with the that is more related to behavioral barriers. While repair policies in the EU, so in the European Union, they have been implementing a lot of right to repair policies, but also repair vouchers in France, some region of Germany, Austria. Also, there has been some monetary incentives in Sweden to incentivize households to repair, especially energy using consumer goods. Well, while these repair policies in the EU have increased the number of repairs, the effectiveness of these policies this effectiveness was a lot mitigated by the lack of awareness and engagement of consumers and the lack of trust of consumers in repairers. So there is also a behavioral barrier here for consumer to engage into these circular economy strategies. And basically, in this paper, we look at the potential or lifetime extension of energy using goods through repair triggered by lifetime changes and economic incentives to decrease these economic, technical, and behavioral barriers in mitigating waste generation, resource use, and CO2 emission. So quick review of the literature. So basically, some economic studies looked at how price signals could incentivize households to engage into repair. The main papers were highlighting that decreasing the cost of repair is more effective than increasing the cost of replacement of new goods, which we find also in our papers that in our results that I'm going to present later on. Then the life cycle assessment studies highlight the trade-off that might exist between circular economy and climate change mitigation goals, and especially that repairing more and more energy using consumer goods can have a negative environmental impact. by increasing CO2 emission. And then the behavioral studies identify barriers and enables that influence consumer repair behaviors. And so basically what we try to do here to assess how lifestyle changes and economic incentives triggers repair, the engagement in repair of consumers, where we basically build an interdisciplinary framework that explore these complex interdependencies and trade-off between different circular economy strategies and different disciplines, economics, LCA, industrial ecology, and behavioral science. So how do we do that? How do we assess the impact of economic incentives and lifestyle changes to incentivize households to engage into repair behaviors to mitigate, to advance circular economic goals and climate mitigation goals, where we've built this life sourcing model that is a dynamic general equilibrium model augmented with material flow analysis. We try to track material stock and flows throughout the years, but also waste flows. And we also incorporate key behavioral concepts into the model through the life model that was created by Hazel, Pettifor, Maria New, and Charlie Wilson. So let me just focus here on the consumption part of life sourcing, which is the most important part in this model for this paper. So basically the households have consume a bunch of products and services. So they consume on the right-hand side non-durable goods that are made of food packaging. They also consume what I call semi-durable goods, but those are durable goods such as furniture, clothes, cutlery, and so on. And then they also consume, energy services such as mobility, clean clothes, time screen, and so on, by either sharing goods, going on the sharing market, by sharing a washing machine, a car with other households, or producing at home these energy services by owning a good such as a car and using energy. So basically they either go on a sharing market, or they prefer ownership model and they produce, let's say, mobility by buying a car, using it for themselves and using energy. And this energy using durable goods, the energy using consumer goods that I call durable goods here, they can either be repaired at their end of their lifetime or bought on a new good market. And basically, we have different types of consumers that I will present to you later. We have heterogeneous consumer behaviors, and we integrate in this model the mechanism of lifestyle changes through the life model of Pettifor and al. And I think I will now give the floor to Hazel, who will explain to you the methodology of this life model.
Okay. Can you see me okay?
Yes, all good.
Yep, okay, all good. Yeah, so hello everybody. So I'm Hazel Pettifor from the University of Oxford. The work that I did with Darius was really part of a bigger picture of us trying to introduce good social science into demand-based IAMs. So the life model was really an approach to trying to endogenize lifestyle influences in the models. So the life model itself then is an empirically based static model of low carbon lifestyle. It's theoretically informed, so it's based on a large scale review of the literature on low carbon lifestyles. It draws on big social survey data. And initially we use countries, the UK, the USA, Australia, and China. I know it's kind of limited in terms of country coverage, but we also developed extrapolation methods which allowed us to project the heterogeneity across lifestyle groups onto external data sets and then calibrate those within the countries that we're interested in. So the life model itself then, it characterizes up to 4 different lifestyle types across 3 important elements of low carbon lifestyle. And the first one is low carbon cognitions. The second one is low carbon behavior, and the third one is context. So cognitions then, these are mental processes, include things like values and beliefs. Behaviors are physical, observable activities, actions, or improvements. And for the coupling with the CMCC model, we remap our behaviors. Originally, we used the ASI, the Avoid, Shift, Improve framework. But for this coupling, we refocused and remapped against our behaviors. Importantly, cognitions are major drivers of behaviors, so they influence behaviors. Context shapes this relationship between cognitions and behaviors, and it can be material, so it can include things like income and affordability, but it can also be social, so it includes things like having access to supportive social networks. So I've said the life model characterizes up to 4 lifestyle types. In this coupling, we condense those down to 3 types. The important thing, if you see here from the life model diagram, is you have heterogeneity across these groups, across cognitions and behaviors. So if you look at the extreme upper right of the diagram, you've got this green blob. And this is a group that have very strong high carbon cognitions and subsequently strong low carbon behaviors. At the other extreme, you've got a group at the bottom left quadrant, and they have low carbon cognitions, but interestingly, they have very disabling contexts. They have low incomes, and that affects their ability to be able to engage in low carbon behaviors. You change the slide. Thanks, Darius. Yep, next slide. Okay, importantly in the lifestyle model then, in the life model we can represent and we have equations for 3 different important drivers of lifestyle change. The first one we call context enabled, so that as incomes rise or people have monetary incentives, behavior increases. The second one is cognitively driven and lifestyle change. And this describes how behaviors change as values, beliefs, and intentions strengthen. And the third mechanism is behavior-driven lifestyle change. So that's in the reverse. So cognitions change as people become familiar or learn about behaviors, a bit like a social influence effect. And the important thing about these 3 mechanisms is they're interconnected processes. Okay, next slide. I'm just really going to describe a very, very simple approach to how we do the coupling here between the life and the CMCC model. So initially, then from the life model, we estimate sizes of the clusters, in this case for Japan, across 3 different groups, and a set of behavioral propensity modifiers. And these modifiers capture heterogeneity across behaviors. These are input into the CMCC model. And they influence our equations affecting our decisions. Output from the CMCC model is in terms of changes in behavior, and then we input these back into the life model through the equations for lifestyle change to re-estimate these propensity modifiers. We can also include exogenous forcings that affect directly the CMCC model, but we can also use scenario narratives to run through the equations for changing context in the life model. Okay, back over to you, Darius. Thank you.
Thank you, Hazel. So basically here, this life model is going to inform this heterogeneous here consumer behavior. So we have like 3 different households who are going to make different decisions regarding their, oh, I cannot zoom in. Okay, my screen is frozen, sorry. Okay, sorry, my screen is a little bit frozen. Okay, sorry, I have a problem with my MacBook. I cannot do anything. Yeah, Sophia, maybe could you share the screen for me? Let me try and okay. Oh no, it still doesn't work. I don't know why. My screen is frozen.
Let me see if I can share.
Yeah, yeah. Basically my PowerPoint has just crashed and I cannot open it again. Sorry for this.
Okay. Yeah, maybe
Yeah,
I
good.
saw your presentation.
Yeah, okay, good. Sorry.
If you could share, send briefly the presentation. Sorry for that. By email.
Yeah, after yes, just yeah, after. Yes, this one, great. All right, so basically to incorporate these three different households into the CMCC model, thanks to the life model, and to incorporate these behavioral parameters that we have from the life model to the CMCC model, we need to completely recalibrate all of these parameters of life model um, to basically be consistent with the scale and structure of this dynamic general equilibrium model that is augmented with material flow analysis. Because the life model and the CMCC model have completely different structure and scale, and to avoid unrealistic step changes in behavioral modeling, in CMCC, we need to completely recalibrate the life model, the parameters in life model, and that will after input into the CMCC life. So basically, we try to find the value of the CMCC's behavioral modifiers such that CMCC behavioral observation match the life behaviors. Next slide, please. I think I have some animations here. Yeah, you can just go to the, yes. Okay, thank you. So basically here we have three main types of households. Can you, yes, click on, yeah, thank you. We have the high income group, medium income group, and low income group. The high income group in the CMCC life model is rather highly enabled, but is social and material context and has low carbon cognitions. Then we have the medium income group that has a medium to high income, so is rather also enabled, but is social and material context. And then we have the low income, the medium income group has low carbon cognitions, so he has a very passive behaviors regarding climate change. He doesn't care about climate change, very low environmental beliefs. And then we have the low income group that is not enabled but by his social and material context. He has a low income and a rather low carbon condition, and his behavior is mainly driven by the need to save money. Next slide, please. So basically, this slide is going to be a little bit overwhelming because we have different scenarios. So again, the main objective of this paper is to look at how lifestyle changes and economic incentives incentivize repair behaviors. And from the literature that I exposed earlier, the literature identified three enablers factors to incentivize circular economy related consumption behaviors, which are economic incentives, behavioral drivers / lifestyle changes, and barriers to repair. So first of all, we have a set of scenarios for the economic incentives. So first, current policy, we have, so it's just a current policy scenario, and then we implement two policies. The first policies is a repair bonus. Basically, we give to the household a repair vouchers that aims at decreasing the cost of repair. So we increase this repair bonus from 5 to 30% of the cost of repair by 2050. And this repair bonus is fully funded by rising extended producer responsibility fees, such as in France. So basically in France, the recycle part of this EPR fees revenues toward a repair fund. So we do the same in Japan. And the second policy, we do not decrease the cost of repair, but we increase the cost of replacement of these energy using consumer goods. by increasing the extended producer responsibility fee as a percentage of the final price of these energy using goods. And these policies, basically all of these revenues from the CPR fees are redistributed to consumers to make this policy also budget neutral. So basically these two policies are budget neutral. Next animation, please. And then regarding the barriers to repair, we assume two different variants for the barriers to repair, a high barrier to repair vs a low barrier to repair. So in the high barrier to repair, we basically constrain the substitution between replacement and repair of energy using goods. If you remember in the consumption basket of a consumer, they to consume durable goods, energy using durable goods, they either repair or buy new. So basically in the high barriers to repair case, we constrain the substitution between both. And in the low barrier to repair, we do not constrain the substitution. So basically there's a high substitution rate between replacing and repairing these energy using consumer goods. And then we have three main variants for the engagement of household into repair behaviors. We have the known variants in which repair behavior, we have no repair behavior drivers, and this variant basically catches only price and technological effects. We have no lifestyle changes effects or behavior driver effects. Then we have the low carbon condition variant in which we strengthen the low carbon conditions of high income groups. So in this variant, basically mainly the high income groups are going to engage into repair. And then we have the save money variant in which the repair behavior, so the engagement into repair behaviors is solely driven by the need to save money of low income groups. Next slide, please. So what about the results? Yes. So we have a lot of results from this paper, so I'm only gonna give you the main takeaways. First results is that we see that we have some synergies between the repair strategy and the refuse strategy, repair and refuse behavior. Here in the paper, we define refuse as decreasing purchases of new energy using goods. So we see that lowering the cost of repair is more effective than increasing the cost of replacement alone to incentivize repair and refuse behavior. You can see that on the right hand side graph, the B graph, the evolution of the ratio repair to brand new purchases. So I'm going to give you the quickly the color code. Green lines represent repair vouchers, so when you give repair bonuses, repair voucher to consumers, and the blue lines represent the EPR fees, so when you increase solely the cost of replacement. And you can see on the right hand graph that when we lower the cost of repair, so the green end lines, it's so this is where we have the most engagement and uptake in repair behaviors, and same for refuse on the left hand side graph, which tells you give you the evolution of energy using goods purchases compared to current policy. You can see that the solid green line is the one that decreases the most new energy using goods purchases for when we implement a repair voucher. However, this policy effectiveness is highly reduced by the repair barriers. So solid lines are when you have low barriers to repair, and the triangle lines are where you have high barriers to repair. You can see that on the left hand side graph, when you have high barriers to repair, basically households do not engage into repair. And this is the two solid lines, the green and the blue. No, sorry, the two triangle lines, the green and the blue. There's a very low engagement into repair because basically households are very constrained in their engagement into repair, while when you lower these barriers to repair, they can fully engage and respond in a positive way to these price signals. Next slide, please. Just go previous slide, please. No, the previous one. Previous one. Yes. Yes, thank you. While there might while there is some trade-off between refusing behavior and repair behavior, we see that there are some synergies between refuse behavior and repair behaviors. We find that there are some trade-off between repair and rethink behaviors. Here, rethink behaviors are related to the sharing economy. Basically, when you give repair voucher to household, this incentivizes maintaining product ownership. So this is quite intuitive. And if you give a repair voucher to a consumer to repair its car, this consumer will keep on owning a car and it will not be incentivized to go on the sharing market. However, this is completely different when you increase the cost of replacement of this energy using good, when you increase the cost of replacement of this energy using goods, actually households are more incentivized to go towards the sharing economy than the repairing economy. So you might have some trade-off between these two circular economy strategies. And yes, next slide, please. So basically, these two results that I've presented to you before are all without lifestyle changes. What if now we incorporate this behavior driver scenarios and these lifestyle changes? Well, we can see that lifestyle changes are antecedent to repair policies. When we strengthen the low carbon condition of high income groups, this significantly enhances the effectiveness of economic incentives and lowering barriers to repair. On the top top right graph, you can see the evolution of the ratio of repaired compared to brand new purchases. The green solid line is the green solid line is the scenario in which we strengthen the low carbon condition of high income groups with a repair voucher. The orange line is the one with no lifestyle changes, so the result that I presented to you before, and the blue solid line is the one in which repair behaviors are solely driven by the need to save money. Well, you see that the green line is when we have the highest uptake engagement into repair behaviors driven by the strong low carbon condition of high income groups. So it's very important to strengthen the low carbon condition of these high income groups to enhance the effectiveness of these repair vouchers, but also these EPR fees. And again, these lifestyle changes, the potential of these lifestyle changes or economic incentives can only be unlocked if we lower the barriers to repair. As you can see here again, the triangle lines, there is basically no engagement into repair or into refuse or into sharing. So these high barriers to repair completely lock the effect of lifestyle changes. Next slide, please. Okay, so right now I'm going to finish with the findings related to resource use, waste generation, and CO2 emissions. Next slide, please. Yes, thank you. So all of these previous results translate into, of course, resource use and waste generation and CO2 emission. And again, economic incentives and especially repair vouchers and lifestyle changes, especially when we strengthen the low carbon condition of high income groups, advances the circular economy goals and resource security goals. We can see that when we give repair vouchers to this household, and when we strengthen the low carbon condition of high income groups, we resource imports decreases by 20 million tons per year, and waste generation decreases by 12 million tons per year compared to a current policy scenario, which is quite a lot. And all of these benefits are translate into, of course, domestic material consumption. You have lower domestic material consumption, but also lower gross addition to the in-use stocks. And however, if we do not strengthen this low carbon condition of high income groups, and when the repair behaviors are solely driven by the need to save money of low income groups, where we can see that actually these price signals and lifestyle changes are not enough to advance circular economy goals. We have a very low decrease of imports, of resource imports and waste generation in the long run. Next slide, please. And finally, so our findings do converge with the studies that find that there might be a trade-off, a tension between SDG 12 and SDG 13. We find that energy efficiency and substitution mechanism create a trade-off between circular economy and climate change mitigation goals. Especially when you implement repair policies. And this is due mainly to the increased reliance on older repair goods that raises household energy consumption due to lower aggregate energy efficiency, while there is a decrease of final energy use by the economic activities from the waste treatment, because lower waste is being treated, but also lower goods are being produced, especially energy using goods. So you have lower energy that is used by the economic activities. However, this is completely this decrease of energy use by these economic activities is completely offset by the increase of energy use by the household, and this translates in CO2 emission. By 2050, you have an increase of cumulative CO2 emission by approximately 40 million ton of CO2 equivalent. And this is mainly driven by the higher energy consumption of household. However, this higher cumulative CO2 emission that are due by the higher consumption of energy by consumers is a little bit offset, mitigated by the lower waste CO2 emission that come from the treatment of waste through incineration sector. You can see here the lower hand graph, the yellow bars represent the CO2, the reduction of CO2 emissions from the incineration sectors, and the peak one, the cumulative CO2 emission of the economy sectors that are mainly driven by of the economy, sorry, that are mainly driven by households. So we actually have a conflict between, we find a conflict between SDG 12 and SDG 13. We advance circular economy goals, but we do not advance climate change mitigation goals. Next slide, please. So a very quick takeaways, policy implications. So combining economic incentives with policies strengthening local condition and also addressing existing barriers are very key to advance circular economy goals. Making repair cheaper is more effective in encouraging repair than simply raising the cost of replacement. And this is all the more true for low-income groups who are more sensitive to price signals. So I think that this result is all the more important for lower-income countries. And then we saw also that price signals alone are not powerful enough, and we need targeted awareness campaigns to strengthen low carbon conditions, especially in high-income groups. So these targeted educational awareness campaigns are very important for high-income countries in which you have a higher share of high-income groups. And lowering barriers to repair are key here. If we do not lower barriers to repair, we cannot unlock the potential of price signals and lifestyle changes in incentivizing households to engage into repair behaviors. And the environmental impacts of these policies require careful consideration, especially in countries where the energy mix remains highly carbon intensive and for goods where the use rate dominates life cycle energy. Because of course, if you are in a country with a very decarbonized energy mix, having a higher share of old energy inefficient goods, I mean, you basically do not care if the consumption of energy increases because you have a lower carbon intensive energy mix. And I'm done for today.
Okay, thank you very much, Darius and Hazel. Yeah, thanks a lot for the presentations of very many aspects of this topic, I think. So yes, it's a complex topic. That's from what we saw. I mean, we have the behavioral aspects, we have the very many different policies and the very different responses and how it links to implications on emissions, etc. So a lot of angles, and I think quite some progress in modeling, and especially also the social and behavioral response, which I think is really interesting. Also showing some limits of some policies, right? I think that's also interesting to see that some policies don't have a large impact, whereas others or combinations are much more successful. I think that's really the needed evidence also for policy design in this aspect. So thanks a lot. We have now 10 minutes for questions and answers. I think, yes, people feel free to also intervene or write a question in the chat. I mean, one question maybe to start with is you mentioned the context is very important, right? I mean, and on the empirical front, of course, data availability in this is challenging. From your experience, maybe also going to Hazel, but also Darius, talking about we've seen the global plastic summit, etc., other aspects. So globally, looking at other continents, etc., how far you think these results carry over, or what is needed to better understand also other contexts than Japan, which has, as you explained well, a long history, or Europe also, which is also, let's say, it has quite some, let's say, history in the policy. And I mean, based on your, let's say, point of view, or what would be needed to improve understanding also the global scale of the issues. And yeah, please, if you have questions, put it in the chat box and or raise your hand in the meantime.
Yes, maybe I can respond to this. So I do think that, I mean, we only look on Japan, which is a very little country. And of course, even if we look at other countries such as the EU, Japan, South Korea, or other countries that are, let's say, resource poor, even if we can see some tension between SDG 12 and SDG 13, these lower resource imports will translate into lower materials being extracted, lower materials being refined, and then in other countries which are resource rich, this will translate into lower CO2 emission, right, from the extractive industries, from the production of refined materials. So even if in this resource per country that I'm looking at, locally the CO2 emission, the cumulative CO2 emission can increase, well, in other countries, the CO2 emission can actually decrease because you have lower materials that are being produced and extracted, right? So I think there's, as you say, there is maybe a need to have a global perspective and see how how advancing circular economy goals in resource poor countries translate into advances, maybe climate mitigation goals in resource rich economies, right? So yeah, so we only gave here one side to the coin, but there's the other side to the coin, which are resource-rich countries and that produces all of these materials and that need a lot of energy in their production processes, right? So yeah.
Yeah, maybe I could respond from the empirical perspective. It's really difficult when you're empirically modeling to get away from some of these big drivers. So certainly when we were looking at our data, context was, the important drivers were income, education, though behind education, we suspected it was more about digitalization. I think the questions we had in the survey were particularly about use of digitalization and also the influence of society. So kind of the next phase of our work on these types of models is to look more specifically at digitalization as a driver of lifestyle and impact on behaviors. But again, it's difficult once you get things like GDP in equations. It just is such a huge impact that it's hard to find these other important drivers that are kind of masked.
Yeah, I think digitalization is a very important one, and also several people, maybe also on the call, have been working on these topics. So that is definitely something that could be probably further explored. Yes, maybe one other question for me, and then let's go first to the question by Cindy Azuero. Could you explain a little bit more how the modeling of awareness campaigns and how these changes behavior was modeled? So how these awareness campaigns how they affect behavior. And do you have any insights on how the results change if a country does not rely as much on incinerators to manage waste?
So for the first question, so we do not per se model awareness campaigns. This is just like a policy implication. And when I say that we should implement awareness and education campaigns, because as you saw from the life model, we have a scenario in which we strengthen the low carbon condition of these high income groups. And how do you strengthen this low carbon condition of high income groups? By, for example, implementing awareness and educational campaigns. So maybe Hazel, you can correct me on this point if I'm wrong. And for the second part, any insight on how the result change if the country does not rely as much on incineration to manage waste? Well, you have two cases. Either the country relies a lot of recycling. I do not know right now of any countries who that recycles this much. There's maybe one of the few is maybe South Korea, but we have to see. I mean, there's the recycling of the materials in South Korea are very of poor quality, and basically they are exported elsewhere. So I don't think that's a good example. And however, then you have, if the country does not really incinerate or recycles, where it does a lot of landfilling, right? And landfilling poses also air pollution issues and maybe biodiversity losses issues, because you need to have all of these landfill capacities. So yeah, I mean, this is my only response. So mainly if you look at countries who have a higher share of recycling and landfilling capacity, you will see a lower, maybe a less beneficial outcomes on cumulative CO2 emissions from lower waste being treated through incineration sector, because you go through recycling and landfill capacity. And yes, and also there's also the case in which countries export illegally a lot of wastes instead of putting them in landfill sites or incinerate and recycling. But this goes back to Johannes' point of view on having more a global perspective on this subject, how advancing circular economy goals in, let's say, North countries, on the richer countries could impact could completely redirect the waste flows that are right now diverted towards Southeast Asian countries and recently sub-Saharan African countries.
Yeah, I just add to that really. So we talk about strengthening low carbon cognitions. What we're really talking about is strengthening people's values, their beliefs, their perceived ability to act. So we know from our empirical work, some of these groups are receptive to social networks. They're influenced by, influential institutions, familiarity. So what you could do, I know we talk about building awareness, but we could make, desirable behaviors more observable. So we engage in the mechanisms of spillover or social influences, but it's not easy to change people's beliefs and values. They kind of change slowly over time. Yeah, that's not meant to be negative, but
it's a challenge. Yes,
yeah.
no, that's what I take, and important to recognize. I think it makes a really great point and a contribution to this discussion. Also the illegal point that you mentioned, of course, illegal waste trade and export, etc. So the monitoring is also important at some point. Other issues, but I think the behavioral component really came out very nicely, and the policy also angle and different effectiveness. That was really interesting. Great. Thanks a lot for sharing these insights. I think the work is still under works, right? I mean, some of it is published, some is ongoing. So really, please look forward on our website also in case. Yes, we almost at the hour. So thanks a lot, Hazel. Thanks a lot, Darius, for sharing the thoughts. And yeah, please feel free to be in touch for receive more information on the project. And yeah, we will also publish the video for people who haven't seen it in case with also the links and of the presentation. Thanks a lot for your time this afternoon. Have a nice rest of the day and see you soon for the next webinar from Prisma or CMCC. Bye, everyone. See
Thank
you.
you.
Thank you. Bye-bye.
Bye.